So for the fourth quadrant, we have first quadrant with all functions are positive, so sine, cos, and tangent are all positive. And second quadrant, we have only sine to be positive and others are negative. Third quadrant, we only have tangent to be positive. And fourth, we have only cos to be positive. Some people remember as all positive, A, sine positive, S, tangent positive, T, and cos positive, C. So A, S, T, C. Some people remember as this. So this is about the positive quadrant. However, for me, I have three diagram over here, which I remember them separately. For sine, I have the top two to be positive and lower two to be negative. And this actually depends on the symmetry we're talking about later. So the symmetry of sine and cos. For cos, I have the right to be positive and left to be negative. And for tangent, we have so 1 and 3 to be positive and 2 and 4 to be negative. So there are some kind of symmetric pattern in it. So this actually relates to the further symmetry properties. So for cos, if we have a negative sign, negative theta, then the cos negative theta is actually equal to cos theta. So this point, the cos value is equal to this point. This is actually why I'm remembering it like the right two quadrant are positive, because they have the same sign, which is this property over here. So for sine, I have sine negative theta is equal to the negative sine theta. So it's flipped. So this point, if I have sine theta, then this point I have negative sine theta, which is exactly here. So instead of the positive in the fourth quadrant, I have a negative here. And for tangent, tangent negative theta is negative tangent, which is exactly over here. So instead of the positive tangent in the fourth quadrant, I have a negative tangent over here. Then what about complementary angles? So complementary angle is defined as if I have 180 degree and then I have a theta, then the 180 minus theta is my complementary angle. So, or else we can say, so the complementary angle is talking about 90 degree. So half pi. If I have a theta over here, then this one is half pi minus theta, which is the complementary angle of theta. So for sine, if we have theta, the cos theta is equal to the sine pi over 2, pi divided by 2 minus theta. So why is that? We can actually directly see it on the graph. If we have theta, this angle, the cos theta in this triangle, which we talked about earlier, is the x coordinate of the point. So we have this line, cos theta. Then what about pi on 2 minus theta? So it's this point. This angle is pi on 2 minus theta. And the sine of this angle, when we see this triangle over here, is actually this side over here, right? Because we have sine is equal to this side divided by this side, where the hypotenuse should be 1. So that's why the cos theta is equal to the sine pi on 2 minus theta. So they both represent this line. So in a rectangle, the upper and lower should be same. So that's why they are the same. And same for other quantities. You can somehow prove it using the graph. And that's about complementary angles. So now let's talk about Pythagorean identity. The cos square plus sine square is equal to 1. And later on you'll relate with sec square, tangent square, and their identity as well. But this one is about the Pythagorean identity, which is very important. So cos square plus sine square is equal to 1. And here's a table you should probably remember, which is just the triangle we talked about earlier. So this angle should be pi on 3, pi on 6, 90 degree, and another triangle, pi on 2 again, and 90 degree. So their sides, this one should be 1 root 3 and 2, 1, 1 root 2. And this whole table is only about these two triangles. So maybe I prefer remembering this two triangle instead of the table. Okay, now we have graphs of circular functions. So now we have amplitude and period. Amplitude means the highest point to the if you learn physics, you maybe know what are the nodes and the antinodes. And so yeah, the amplitude is this length over here, or you can say it at this length. The period is if you take a point and the time you take or the angle you take to get it back to the point you have, the initial point you have. So it's actually the third point, 1, 2, 3, the third point of the initial y value. And same for cos, you have, so the period is 2 pi, which is the whole circle. So whole angle should be 2 pi. And the amplitude is just the radius, which is 1. Same for cos. You also have the unit circle before. So you have amplitude of 1, which is this length or this length, and the period of 2 pi. So if you extend the graph, you may get something like this. So here should be 4 pi, and here should be negative 2 pi. So sine and cos are just continuous graph, so they never stop. So they extend to positive and negative infinity. And no matter how long they extend, their amplitude is always 1 and the period is always 2 pi. Same for cos. You can also extend like this and that way as well. So tangent is a little bit different. It have the asymptote, which using the dashed line, and you have the amplitude at 2 pi times 3, 2 pi times 5. So you can actually write it as so the 2n plus 1 represents an odd number, which is just like 1, 3, 5, 7, or if you have -1, -3, and so on. And you multiply by pi divided by 2. And this is actually a general form of asymptotes of all the tangent graph. The amplitude is undefined, so there's no amplitude for this graph, and the period is 2 pi. So the period is actually talking about how long do you need for the graph to be repeating itself. So for sine, if you take this as an initial point, so back to the same point over here, you need 2 pi to start another period. Same for cos, you need initial point and final point, which is 2 pi between them, and after the 2 pi, you start a new period. Same for tangent. If you take asymptotes as the boundary of the period, you can have this as a whole period, and after pi on 2, you can have a new period, and new period, and new period, so forth and so on. So the period is pi. Graphs of circular functions of the type. So y equal to a times a is the amplitude, and you have sine function n times bracket t plus or minus another constant epsilon, and then plus or minus b. So if we look at this graph over here, we can tell the amplitude is actually 2. So how can you tell it? If we have the top point, which is 1, the lowest point, which is -3. If we have the modulus of them, or you can say 1 plus, which is 4, then you divide by 2. So we're actually taking the median value of the highest and lowest point, and then take the mean. Then we have -1. If we take this -1 and draw a line over here, then it's actually the same as when we talk about the cos. So we have the top is 1, the bottom is -1, so we have the mean to be 0. And this 0 actually can be seen as a reference point. And between the reference point, reference line, and the top, and the reference line, and the bottom, you can have the amplitude. So this represents the amplitude. And what about the period? As I talked about earlier, so the period is the time or the theta you need, or the t you need to repeat the graph. So this as initial point and this as final point, the period should be minus negative. We can see the coordinate from here, which is so you have a formula for your period, 2 pi divided by n, and n is a thing you take out, so it's actually written as y equal to a sine nt plus or minus epsilon, n epsilon, and you take the n out, so it becomes a sine n bracket t plus or minus epsilon. So n is a constant in front of the t. And here we have 3, so we divide by 3. So it's 2 pi divided by 3, which is the period. The graph is the same shape as y equal to 2 cos 3t, but translated pi divided by 3 units in the negative direction. So in the negative directions means to the left. In the direction of t-axis, and 1 unit in the negative direction of y-axis, so 1 unit down. And left by pi divided by 3. So this circular functions, sine, cos, and tangent, always relate to transformations. So translation, dilation, and reflection. That's something you should learn about in other chapters. And let's move on. Solutions of trigonometry equations of the type sine x equal to a. So if we have, for example, sine so this is a fact, and we can exchange it as so if we want the angle pi on 4, then we use the sine negative, or that's what you've been told how to find the alpha. And if we want the sine pi on 3 or pi on 4, then we get the answer, then we use this method over here. Yeah, I guess that's it. That's the whole chunk of chapter summary of circular functions. Thank you for listening.